Hey, what's up everybody? In this portion of the course, we're going to continue to solidify our understanding of the two pointers pattern by solving another problem from our Leetcode patterns list. Our next problem can be found by filtering the list like so. In this problem, we're asked to find two lines which together with the x-axis forms a container such that the container contains the most water. To do this, we are to use in, which is an array of non-negative integers where each represents a point at a coordinate that looks like this. First of all, let's demystify the problem description and try to understand what they are asking of us. We're given a graph that looks like this. And we're told that in vertical lines are drawn such that the two endpoints of a line I are coordinates I and AI and I and 0. AI just being the value at the ith index of our input array. Now, given the coordinates for the two endpoints of each of the above mentioned vertical lines where each coordinate is represented by an ordered pair where the first value represents our x coordinate and the second value represents our y coordinate, we can visualize each line like so. Now you'll notice that on my version of the example graph, I did some reorganizing of the x and y axis coordinates. I've shifted our x-axis coordinates up 1 such that our x and y-axis intersection coordinates are -1 and 0 instead of 0 and 0. And yes, I'm aware of the effects of altering the origin or the point at which the x and y-axes intersect in a coordinate plane, but I did that to make the indexes of the input array coincide with the x-axis of the graph given as an example in the problem description. I guess we could also consider that our input array is 1 indexed instead of 0 indexed, but all of that adds too much additional confusion in my opinion, so like it or hate it, we're left with this. So we're asked to find two lines which together with the x-axis forms a container such that the container contains the most water. To do this, we will make use of two pointers, starting each pointer at opposite ends of the array and calculating the size of the containers formed by the two lines and keeping track of the highest value. To decide which pointer we should move inward, we will simply keep the tallest line of the two and do away with the shorter line in hopes of finding an even taller line that together with the width formed by the x-axis will form a container with a larger area. Once we've reached the point at which our two pointers intersect, we would then just return our maximum container area and we would be finished. So let's go ahead and get into writing some code. Okay, so to start we want to make sure we're in our Python source coding interview patterns directory. And within this directory you should have a folder called two pointers from the last section of this course. And we're also going to change directory into the two pointers directory. And within that directory we're going to make another directory called container with most water. And we'll go ahead and change directory into container with most water. And within this directory we will go ahead and get our virtual environment set up by running python 3 mvmv, and we'll call the virtual environment folder v and v as well. And let's just go ahead and clear. And then we can ls here and we see that we have our virtual environment folder. So from here we can just go ahead and activate our virtual environment. And you can confirm that your virtual environment is running by running the environment command and grepping the environment variable env. And if your virtual environment is running, you should see this virtual environment variable that has the path to your virtual environment. Now let's go ahead and just make some room here. And from there, we're just going to create a file that we're going to call container with most water.py. And we can go ahead and open that file using an IDE or text editor of your choice. I'm using Vim, so I will do Vim and then the file name. And to start, we just want to write code for what is essentially an entry point to our script to run our algorithm. So we're going to do if name equals main. We're just going to print the name of our function, container with most water. And we haven't created this function yet, so don't worry. And we're going to pass an array to this container with most water function, which is going to be the array passed within the problem example. So in the example, the input for height here is going to be 1, 8, 6, 2, 5, 4, 8, 3, and 7. So we'll just copy that. Before we go back to the code, if we change this to Python 3, we see here that the height is what's the input to this function. So in our code, we're going to test using this example input here. And the expected output is 49 for this example. So we can just go ahead and paste that in here. And now we just need to write the code for our function. So we can define container with most water, and it's going to take in y-axis. So I know that in the problem, they're calling the input to this function height, but I'm actually going to use height for a different variable, and for our purposes, y-axis makes more sense for the array of heights. So we can go ahead and first let's make some space here. And we can go ahead and set max area equal to 0. So max area is going to be our final answer. We're going to try and figure out the maximum area that we can achieve using 2 points. So we'll go ahead and do left pointer, which will be the pointer that starts at the 0th index of our y-axis array. And we can also do right pointer, which is going to be length of y-axis minus 1, which is going to be the pointer that starts at the very last index of our y-axis list. And I apologize if I use array and list interchangeably. I usually write code in multiple different languages, so the terminology kind of gets merged together with me sometimes. So to start, we're going to create a while loop. It's going to continue while left pointer is less than the right pointer. And what we're going to need to do is we're going to need to find the area of what is essentially a rectangle by using the 2 pointers to create our width and using the value at the pointer that has the shortest y-axis for our height. And that's because the container can't hold water beyond the side of the rectangle that is the shortest. So if we have a tall height on one pointer and a shorter height on the other pointer, if we were to actually pour water into a container with walls that are of different size, the water wouldn't be able to be filled past the shortest side. And if this is hard for you to understand, don't worry, I will make sure that everything is understandable by the time you reach the end of this video. So we'll go ahead and do our width equal to right pointer minus left pointer. So the distance from one pointer to another will be the width of our rectangle. And then we're also going to calculate our height, which is going to be equal to the minimum of our y-axis left pointer and our y-axis right pointer for reasons that I just explained. And then we need to calculate the area using those 2 variables, width times height, because the area of a rectangle is of course width times height. And then we need to get our max area, which is basically going to check to see if the area that we just calculated is larger or less than our stored maximum area. So we'll get the max of max area and area. So we want to compare whatever value is stored here to the area that we just got, so that we make sure that our max area is always the most recent maximum area. And what we're going to do is we're going to compare the values at both pointers to check to see which value is lower. And we're going to want to keep the height, or let's just say the wall of the container that is the largest or the tallest. And we're going to want to do away with the shortest wall. Because of course, if we want to calculate the maximum area of a container, we want the walls of the container to be as tall as possible. And if this is confusing for you to visualize, don't worry, I will make things more clear as we progress through this algorithm. So we'll do y-axis left pointer, and we'll compare it to y-axis right pointer. So if the left pointer is less than the right pointer, we're going to increment our left pointer, which means we're going to move past that wall and go on to the next one to check to see if it's a larger wall. And the same thing in the case of the opposite. We will decrement our right pointer to move past the wall that is shorter to see if we can find a taller wall. And after that, we're just going to return our max area. And the code for this algorithm is relatively straightforward and short. So let's go ahead and get into the visualization for how this code is actually working, because I know that some of you might be confused. But first, we'll go ahead and save this, and let's clear. Let's go ahead and just run this file really quick to see if we get the expected output of 49. And as you can see, we get the expected output of 49 for the input from the first example of the problem. So this is the input that we used, and the expected output is 49. So let's get into our visualization. Okay, so let's go ahead and get into our visualization for this problem. And as you've already noticed, I moved the graph that they had in the problem description to our Blackboard because it's going to help me illustrate how we can visualize this problem in an intuitive way. So the first thing that we want to take into consideration is this y-axis parameter, or this y-axis argument. And the reason I changed this from height to y-axis is because it's going to be more intuitive for my explanation in particular. So we first want to take into consideration what our y-axis looks like. So our y-axis is going to be the input from the problem example, the first problem example in the problem description. So what they call height is what we're going to call y-axis. And that's going to be 1, 8, 6, 2, 5, 4, 8, 3, and 7. So our y-axis, which is what they call height in the problem description example, is going to be our input array. And let's go ahead and write in our indexes as well. We have 0, 1, 2, 3, 4, 5, 6, 7, and 8 for our indexes. Now the reason we're calling this array y-axis is because it's going to represent this here. So this graph, we have a y-axis and an x-axis. And we're actually just going to use the indexes of this array to represent our x-axis values. So our x-axis will be here. So our x-axis is this axis, and our y-axis is this axis. And we can actually go ahead and write out the indexes here, down here on our x-axis as well. So we'll just erase that, and our 0 is going to actually be here. And then 1, and then 2, and then 3, 4, and then 5, and then 6, and then 7, and then 8. So as you can see, there's a bar here for every index in our array, or every point on our x-axis. So this 0 here represents our 0th index in our array, and the value for the y-axis for this 0 is 1, so it goes to the y-axis point 1. And this 1 represents index 1 of our array, and the y-axis value for index 1 is 8. So this bar goes up to a height of 8, and etc. for the rest of these bars. So that's why we call this array y-axis for my explanation. So what are they asking us to find here? Like what do they want to know? The problem is called container with most water. And by container, they just mean that these bars here can be considered like the walls of the container. And of course, this here would be the floor. And the example they have is this blue is the water that's filling in the container. And what container is that filling? That's filling this container here. So we have a wall here, and we have the floor here, and the wall here. So everything within here is the water contained within this container. Now let's erase that because we definitely don't want that showing for our explanation. So that's what they mean by container. So what they want us to find is which two walls form a container that can hold the most water. And there are a couple of things we want to take into consideration when looking at the two walls here. So for example, if we were to choose these two walls for our container would look like this. And as you can see, one wall of the container is drastically smaller than the other wall. This container would only be able to hold water up until the shortest wall, because of course there's no way we can fill this part of it up because there's no wall here. So all of this water would just spill out. So that's the most important thing that we need to take in consideration when we're calculating how much water each container can hold. And the next thing that we need to take into consideration is how we're going to calculate how much water is being held in each container. And that's as simple as getting the area of a rectangle. So for example, if we use these same two walls again as our example, we know that our container can't hold water beyond this point because the wall's too short. So we essentially just need to find the area of this rectangle here. So the area of this is going to be the amount of water that a container containing these two walls or this container will be able to hold. So to get the area for the container here, all we need is width times height. And we have access to both of those data points because we know the height of this short wall is 2 because index 3, the value at index 3 is 2. So we have our height because of course we don't want to take into consideration the height of the longest wall because that's not part of the portion of the container that can actually hold water. So we're going to use this as our height, the smallest one. We're always going to use the smallest one as the height. So we have access to the height. So our height would be 2. And we also have access to our width. Our width is just going to be the value here. So from the point 2 to point 3, that's 1, right? So our width is just going to be 1. And we can easily get that by just subtracting this index from this index, and we would get 1. So our width is going to be 1. So that means that the area for this container is just going to be 2. And those are the two things that you need to know to understand how to visualize this problem. Let's get into actually stepping through this code. So let's erase this and erase this as well. And let's get started. So at the beginning of our function, of course, our max area is going to be 0. And we essentially want to find which two walls form a container that can hold the most water out of all of the containers that can be formed within this y-axis array, or while using the heights of this y-axis array. So it's going to start off as 0, and then this is where the two-pointer method comes into play. We're going to use a left pointer and a right pointer to form our containers. And how that's going to work is our left pointer is going to start pointing here, left pointer, and our right pointer is going to start pointing here. And that's reflected here. You can see our left pointer is starting off as 0. So our left pointer starts here at index 0. And our right pointer is starting off as the length of our array minus 1, which gives us the last index of our array. This will give us the last index of a 0-indexed array, because the length of the array is 1, 2, 3, 4, 5, 6, 7, 8, 9. And the last index of the array is 8. So we subtract 1 from the length of the array. So 9 minus 1 is 8. So this is going to give us the last index of the array, which is 8, which is where our right pointer is going to start. And essentially, for the entirety of this function, we're just going to iterate through this while loop. So the while loop is going to iterate while left pointer is less than right pointer. So that means that once this right pointer and this left pointer both reach a point where they collide, wherever that may be, then our while loop is going to terminate. And for that very reason, this solution is going to be, or is going to have an O of n runtime, but we'll get into that later. So at the beginning, left pointer is less than right pointer, because left pointer is 0 and right pointer is 8. So what we do is we calculate first the width, because remember, to get the area, we need width times height. So first we will calculate the width. Right pointer minus left pointer is the width. Because to get the space in between these two indexes, we just subtract the value at left pointer from the value at right pointer. And we get 1, 2, 3, 4, 5, 6, 7, 8. Because 8 minus 0 is 8. So our width is going to start off as 8. And for the height, we're going to get the minimum for the value that is at each pointer. So our right pointer points to index 8, and index 8 points to the value 7 for our y-axis, or for our height. So that means that this bar is going to have a height of 7. And then for our left one, the left pointer index resolves to the value on the y-axis 1. So the left pointer's bar is only going to have a height of 1. So here we want to take the minimum of these two. Which one is smaller is the one that we want to take. That's why we're using this min function on these two values. And remember why we need to do that, because this is the container. And we have this wall here that's much larger than this wall here. This container here can actually only hold water up until here, because there's no way that we can hold water up until 7, because what's going to hold the water in here? So actually this container can only hold water up until here. That's why we're getting the minimum of these two. So we have our width and our height. So our width is 8 and our height is only 1, because the minimum of these two is this one here, which is only a height of 1. And then we calculate our area, which is width times height. So 1 times 7 is the area of this container, or the amount of water that this container can hold is 7. So for our max area, which is here, we're going to get the maximum of the area that we just calculated and whatever the max area currently is. The max area is currently 0, and our calculated area is 7. So of course, 7 is greater than 0. So this is going to change to 7 for now. And before we move on, let's go ahead and erase this. So now at this point, we need to move one of these pointers. And remember, the goal of this entire problem and the goal of our algorithm is to find which of these containers can hold the most water. So to decide which pointer that we want to move, we're simply going to compare the value at left pointer and the value at right pointer. So we're going to compare the size of the wall for the left pointer to the size of the wall for the right pointer. And whichever wall is smaller, we're just going to increment that pointer. Because if the wall is smaller, there's a chance that the wall at the next index will be taller or have a greater height, which would result in a greater area for our container. Because if we were to move our right pointer, when we know that the left pointer's wall is smaller than the right pointer, it wouldn't make sense because we already know that this wall is taller than this wall. So essentially here, we're just checking to see which wall is bigger. Whichever wall is bigger, we're going to keep. Whichever wall is smaller, we're going to increment its pointer in hopes that we can find a larger wall for that one. So in this case, our left pointer has the smaller wall, so we're going to increment our left pointer. So we'll move this up 1. And this else is, of course, if the right wall was smaller than the left, but that's not the case right now. So then we're back to the top of this while loop, and we check to see if left pointer is less than right pointer. It is, so we can still continue with this while loop because 1 is less than 8. And then once again, we're going to calculate our width. So right pointer minus left pointer, so 8 minus 1. So our width is going to be 7. So the space between this wall and this wall is 7. 1, 2, 3, 4, 5, 6, 7. And then for our height, again, we're going to take the minimum of the two walls. Which one is smaller? So we have this wall has a height of 8 because at index 1, we have a height of 8, which is reflected here. And for this wall, we have a height of 7 because at index 8, we have a height of 7, which is reflected here. And 7 is indeed smaller than 8. So for this line of code, we're going to take the minimum of the two, which is 7. So our height's going to be 7. Our width is going to be 7 as well. And then we'll calculate the area width times height, which is 7 times 7. And 7 times 7 is 49. So this area right now is equal to 49. And then we have our max area where we want to take the maximum of the two, our current max area, which is 7, or our current area here, which is 49. And of course, 49 is greater than this here. So this is going to change to 49. And we can go ahead and erase this as well. And then once again, we're going to arrive at this code. So this code here, once again, is going to compare which wall is smaller. So whichever wall is smaller is the one that we're going to move the pointer for. And in this case, the right pointer's wall is smaller than our left pointer's wall. So this condition would not resolve to true. So we would go to this else, and we would decrement our right pointer. As you can see here, we're decrementing the right pointer, not incrementing like we did with the left. And that's because the left pointer goes from left to right, and the right pointer goes from right to left. So we need to bring our right pointer this way. So we're going to decrement it. 8 minus 1 is 7. So we'll point our right pointer to 7. And once again, back to the top of the for loop we go. Our width is going to be right pointer minus left pointer. Right pointer is 7, subtract 1 from 7, we get 6. Our width is 1, 2, 3, 4, 5, 6. And our height is going to be the minimum of the two walls. So this wall is 8 and this wall is 3. So of course we're going to use 3. So we'll do 3 times our width, which is 6. So 3 times 6 is 18. So our height's going to be 18. Our max area is greater than 18, so we're not going to update our max area. And once again, we'd arrive at this code here. Which wall is smaller? Our right wall is still smaller with a size of 3 compared to 8. So again, we're going to decrement our right pointer. And we arrive back at the top of the for loop. Left pointer is still less than right pointer. Left pointer is 1, right pointer 6. The width here is going to be left pointer, which is 6 minus 1. So the width is going to be 5. 1, 2, 3, 4, 5. And let's go ahead and write this one out. So this is going to be our width, which is 5. The bottom of our container, and the width is 5. And then our height's going to be the minimum of our two walls. So this is one wall and this is the other wall. The minimum of the two walls is just going to be 8. They're both the same size. So our height's going to be 8. So let's draw this out. So that's our container with a height of 8. And then we'll end up here where we multiply width times height. So 5 times 8 equals 40. And then we'll compare this 40 to our current max area, which is 49, and 49 is still larger than 40. So still this container isn't bigger than the container that we already found. So let's go ahead and erase this container. And once again, we'd arrive here. And at this point, we check to see if the left wall is less than the right wall, and it's not. They're actually the same size, so we're still going to do this else and decrement our right pointer. So we'll move this to 5, and then back up to the top. Our width is going to be 5 minus 1, which is 4. 1, 2, 3, 4. Our height's going to be the shortest of the two walls, this one and this one. So this wall is the shortest. So our height's going to be 4, and our area is going to be 16. 4 times 4 is 16, which of course is smaller than 49. So once again, we're just going to move our pointers. And the right wall is still less than our left wall, so we're going to decrement our right pointer. So this is going to go to 4. And then back up to the top, width is going to be 4 minus 1, which is 3. 1, 2, 3. Height's going to be the shortest one, the shortest wall, so 5. So 3 times 5 is 15. So the area of this container is only going to be 15, which is going to be less than 49. So once again, we're going to end up down here, and this wall is smaller, so we're going to decrement our right pointer again. I don't know what that arrow is, but this is my life. And back at the top of our while loop, our width is going to be 3 minus 1, which is going to be 2, 1, 2. And our height's going to be the height of the smaller wall, which is this one, which is 2. 2 times 2 is 4, so the area of this container is 4, which is definitely smaller than 49. So we're going to keep 49 as our max. And back down to here, of course, our right pointer's wall is shorter than our left's, so we're going to decrement our right pointer. And we'll erase that disgusting arrow and up to index 2, or back to index 2. And then back to the top of the for loop, and still left pointer is less than right pointer. So we're still going to do an iteration. Width is going to just be 1. 2 minus 1 is 1. Only one space between these two walls. Then the height's going to be the lesser of the two. So the one at index 2 is only a height of 6. So the height of this container is going to be 6. And the width 1, 6 times 1 is 6. And when we compare to the max area, 49 is definitely greater than 6. So we're going to end up down here again, and we're going to decrement this right pointer because the wall on the right pointer is shorter than the one on the left. So this will then point here. And then back up to this while condition. And this while condition is while left pointer is less than right pointer. We continue to do this work. But right now, left pointer and right pointer are equal. So we're no longer going to do the code in here. This while loop will terminate. And once out of the while loop, we're just going to return our max area, which is 49. And that is how you can visualize container with most water. So let's go ahead and get into time and space complexity here. So as you saw, our right pointer and our left pointer are going to share the work of moving through our y-axis array. So if we say that our in is equal to the y-axis array, or actually let's be more specific, in is equal to the length of our y-axis array, then our time complexity is big O of n. And that's because in the worst case, we're only going to need to touch every element in our y-axis array one time. And that's because these pointers never move past each other. Once these pointers meet, then we're no longer going to iterate through the array. So that means that, for example, in this case, our right pointer iterated through all of these items, and our left pointer iterated through these items. So both the left and the right pointer shared the work of iterating through this array, and we only have to iterate through once. We only need to touch the elements within this array one time. And that's why this solution's time complexity is O of n. And for our space complexity, the solution is O of 1. And that's because we don't use any extra space for this algorithm. The amount of space that we use is constant. It doesn't scale with our input y. And that is going to be it for this problem. I hope that I was able to help somebody come to some type of understanding, and I will see you in the next one.